Hello, students. A very good morning to all of you. I hope you are staying home and staying safe and following all the other instructions to keep in good health. Now, today I am picking up a topic that is word problems based on two digit numbers from the chapter of a pair of linear equations in two variables. Now, let us consider a two digit number, say 28. Now, we have 8 at the units place and 2 at the tens place. So, we get the number as 2 times 10 plus 8 times 1, that makes it 20 plus 8 equal to 28. Now, various kind of statements are involved in these problems. Before attempting any problems, I am taking a variety of statements that are involved in such questions. For example, generally the question begins with a given two-digit number. Now, the digits are unknown. Say I have taken x at the tens place and y at the units place in the given number. So the number becomes 10 times x plus 1 times y, that is 10x plus y. And if the problem says the number obtained by reversing the order of the digits, then the mathematical expression that you get is, since x and y have now interchanged their places, so we have y at the tens place and x at the units place. So the number becomes 10y plus 1x. Now, say one of the statements is the sum of the digits of a two-digit number. You can very easily understand what this means. Sum of the digits. The digits are x and y, so obviously their sum is x plus y equal to whatever the sum is given to be. Say the question involves the digits differ by a number, say a. Then the equation will be x minus y equal to plus minus a. Now, why plus minus a? Why not just a? Because in all such problems, they involve two mathematical statements. In some of these, which involve the differ statement, the other statement fails to identify whether x is greater than y or y is greater than x. So we use the equation x minus y equal to plus minus a, because we have not been able to identify whether x is bigger or y is bigger. Either one of them can be bigger. So if x is greater than y, you have x minus y equal to plus a, and if y is greater than equal to x, then you will have x minus y equal to minus a. But there are other problems in which the second statement does reveal that x is greater than y or y is greater than x very clearly. So accordingly, we use the equation x minus y equal to a or y minus x equal to a respectively, as the case may be. I shall illustrate this with the help of a couple of questions after some time. The other kind of statements that we can encounter in these questions is the sum of a two-digit number and the number obtained by interchanging the digits is. So we have already dealt with these phrases, sum of a two-digit number and the number obtained by interchanging the digits. Two-digit number was given by 10x plus y, and the number obtained by interchanging the digits was given by 10y plus x. So we take their sum and we get 10x plus 1x equal to 11x and 1y plus 10y equal to 11y. So we take 11 common, we have 11 times x plus y. Or we can have a statement like a given two-digit number exceeds the reversed number by some number. So the given two-digit number is again 10x plus y. The reversed number is 10y plus x. Their difference, we get 10x minus 1x equal to 9x and y minus 10y minus 9y. Again we have 9 common. So we get 9 times x minus y equal to whatever the difference of these two numbers is given in the question. Or it can be otherwise also be like the number obtained by reversing the order of the digits exceeds the given two-digit number. So in that case you will have 10y plus x minus 10x plus y. So now you get 10y minus y equal to 9y and x minus 10x equal to minus 9x. So we have 9 common, 9 times y minus x equal to the given difference. The last two statements clearly tell us that the sum of all such ulta-pulta numbers, if I can call them for the sake of convenience like this, the sum of all such numbers is always divisible by 11 and their difference is always divisible by 9. Some examples follow. You can see 36 plus 63 is equal to 99 and 63 minus 36 is equal to 27. 54 plus 45 is equal to 99 and 54 minus 45 is equal to 9. 83 plus 38 equals 121 and 83 minus 38 equals 45. Similarly, 93 plus 39 gives us 132 and 93 minus 39 is 54. So you can see that the sum of all such ulta-pulta numbers is divisible by 11. 99, 99, 121, 132, all these sums are divisible by 11. And the respective differences 27, 9, 45 and 54, they are all divisible by 9 and so on. Now let us consider a problem from the NCERT textbook, that is example number 13. The question reads as follows: the sum of a two-digit number and the number obtained by reversing the order of the digits is 66. If the digits of the number differ by 2, find the number. Now, whenever I attempt such a question, in the rough margin, I make this, write the unknown numbers in this fashion. Let the tens digit be equal to x and the units digit be equal to y. So the given number becomes 10x plus y and the number obtained by reversing the order of the digit becomes 10y plus x. Now, according to the first statement, sum of a two-digit number and the number obtained by reversing the order of the digits. So we are talking about this number and their sum. So that gives us 10x plus y plus 10y plus x equal to 66. So you have 11x plus 11y equal to 66. The whole equation gets divided by 11. So you have x plus y equal to 6. This is our first equation. Now you can see from the first equation that we fail to identify whether x is bigger or y is bigger. because we can have x as 5 and y as 1. At the same time, we can have x as 1 and y as 5. It may be like x is 4 and y is 2, or x is 2 and y is 4. And it can be, only these 4 cases, these 4 possibilities. So you can see that either one of them can be bigger. So when the second part of the statement says, question says, if the digits of the number differ by 2, since we now do not know whether x is bigger or y is bigger, we take x minus y equal to plus minus 2. I hope you have understood very clearly when we are going to use plus minus 2, because we have failed to identify whether x is bigger or y is bigger. Generally, this is revealed by the first statement. Now, we will have to solve two pairs of equations. The first equation in both cases being x plus y equal to 6, and the second equation being x minus y is equal to 2 or x minus y is equal to minus 2. Rest of the solution is quite simple. As you can see, that we can use the method of elimination to solve these two pairs of equations, because y is carrying opposite signs in both the equations. So simply by adding the two equations, y and minus y get cancelled. X plus x is 2x, 6 plus 2 is 8, and here again y and minus y get cancelled. 2x is equal to 6 and minus 2. When added, it gives us 4. So either we have x equal to 4 or x equal to 2. Putting the values of x in the first equation, we get 4 plus y equal to 6 or 2 plus y equal to 6. So we get y is equal to 2 or y is equal to 4. Now our given number was 10x plus y. So we put the values of x and y here. If x is 4 and y is 2, the number becomes 42. And then if x is 2 and y is 4, then the number becomes 24. Now you can check that both these numbers satisfy the given conditions. Why? Because if the given number is 42, the number obtained by reversing is 24, and we can see that their sum is 66 that was given to us. At the same time, 4 is greater than 2 by 2, so these two digits differ by 2. And 24 also satisfy both the conditions, since if the given number is 24, then the reverse number is 42. Again, their sum is 66, and again the difference of the two digits here is, in this case, 2 minus 4 is minus 2. So we know very clearly that our answer is absolutely correct. Now I am picking up a very unique problem, and this is from a reference book. Earlier, this question used to be there in the NCERT textbooks. Now the question reads as, a two-digit number is obtained either by multiplying sum of the digits by 8 and adding 1, or by multiplying the difference of the digits by 13 and adding 2. Find the number. Now, if I assume the tens digit and the units digit to be same as earlier, then the initial statements remain the same. So I'll leave that up to you. So according to the given conditions, what equations are formed? It says a two-digit number is obtained. Now my two-digit number was 10x plus y. Is obtained means is equal to either by multiplying sum of the digits. The digits were x and y, their sum is x plus y multiplied by 8, sum of the digits multiplied by 8 and adding 1. Or the other way that the same number, 2-digit number, is obtained is by multiplying the difference of the digits by 13 and adding 2. Now you can see that I have left these two as blank spaces. I have not yet written x minus y or y minus x. Simply because I do not know whether x is bigger or y is bigger. So let us first simplify the first equation. I get 10x minus 8x is equal to 8y minus y plus 1. So the equation becomes 2x equals 7y plus 1. Now you can consider an equation to be two sides of a balance. तराजू के दो बराबर के पलड़े कह सकते हैं. एक पलड़े में 2x है और दूसरे पलड़े में 7y plus 1 है. अगर इस पलड़े में से मैं 1 को बाहर निकाल दूं तो कौन सा पलड़ा भारी हो जाएगा? 2x becomes heavier, 7y will be lighter than 2x because 2x was equal to 7y plus 1, and if I remove the 1 from here, then 2x becomes greater than 7y. So if 2x is greater than 7y, then x is greater than 3.5 times y. Now what does this statement reveal? It simply tells you that x is greater than y. In spite of multiplying y by 3.5, still x is greater than that number. So obviously x is greater than y. So now in this problem, we have been able to identify with the help of the first equation that x is greater than y. So now I can write x here and y here. Thus, by condition 2, we have the second equation as 10x plus y equal to 13 times x minus y plus 2. Now suppose if you fail to identify this in the examination, then what will you do out there? And there is only one way out, and that becomes a very long, arduous route to take. Because since you have not been able to identify whether x is bigger or y is bigger, you will have to take the plus minus sign. And in that situation, you will write the second equation as 10x plus y equal to plus minus 13 times x minus y plus 2. Now, once you will open this bracket with the plus sign, and the second time around you will open this bracket with the minus sign. So you will get two different equations for as far as equation 2 is concerned. And in that situation, you will have to solve with the first equation one of these two equations. So you have to solve two pairs of equations. One of the solutions will give you a valid answer, and the other pair of equations, when solved, it will give you an invalid answer. So that is the price you pay for not being able to identify whether x is greater or y is greater. Your solution becomes very tedious. But since we have been able to clearly detect that x is bigger than y, so I have taken 10x plus y equal to 13 times x minus y plus 2. Simplifying this equation, I get 3x minus 14y plus 2 equal to 0. Now, by observing the two equations equations 1 and equation 2, we can see that we can solve them very easily by the method of elimination, because the first equation had 2x minus 7y plus 1 equal to 0, and here it is 3x minus 14y plus 2 equal to 0. So if I multiply the first equation by 2 and rearrange the terms, we get 4x minus 14y minus 2 equal to 0. Subtracting, we get, that is, we subtract equation 2 from equation 3, which I have shown here. You can see this very clearly. You get, now when you are subtracting one equation from the other, you change the signs of the equation written in the second line. So 3x becomes minus 3x, minus 14y becomes plus 14y, and plus 2 becomes minus 2. Again, minus 14y and plus 14y get cancelled. 4x minus 3x is 1x. Minus 2 and minus 2 is minus 4. So we get x minus 4 equal to 0. So we have x equal to 4. Using equation 1, 2 times x equal to 7y plus 1. So I get 7y equal to 8 minus 1, which is 7. So I get y equal to 1. So I have the value of x as 4 and the value of y as 1. So the required number becomes x, y, that is 4, 1, 41. You can see that again very quickly within a few seconds I can check my answer, that I can obtain 41 either by multiplying sum of the digits 4 plus 1 by 8, so that becomes 5 times 8 as 40 and adding 1, or I can obtain the same number 41 by multiplying the difference of the digits, which is 4 minus 1, that is 3, by 13. So 13 cross 3 is 39 plus 2, 41. So I know there and then that my answer is absolutely correct. I hope you have understood these two questions. Now, based on these two solutions, I am giving you some work to attempt. That is question 2, part 3 of exercise 3.4 from your NCERT textbook, and a couple of more questions I have given from the reference book, and I have also given you the answers. So once you have solved these 3 questions, you can check your answers, and if you face any problems, you know how to deal with that situation. You can send me your difficulty on your class WhatsApp group. Thank you and goodbye.